This is an important video if you are trying to fast. So here we will be discussing the phases of fasting and what does the fasting does to the body and what are the pathophysiological processes which occur in fasting. Yeah, as you know, fasting is a practice that involves abstaining from food for a period of time. It can be done for various reasons. Some people do it for religious practices, some do it for weight loss, some do it for health benefits. Specifically in diabetic patients, it's very helpful in reducing the blood glucose levels. So usually the body undergoes distinct metabolic changes during this phases of fasting. So we'll quickly discuss what are the things that the body undergoes during this phases of fasting. So this image is very interesting that I have taken from the book Harper's Biochemistry. These are the changes that occur during the onset of starvation. If you see specifically, blood glucose will reduce during fasting. The plasma insulin levels that also reduce during fasting. If you see, the plasma glucagon values are increasing during fasting, and blood ketone bodies increase during fasting, and plasma free fatty acids also increase during fasting. The most important thing that you need to observe is that liver glycogen values are completely depleted within 12 hours of fasting or starvation. So coming to the phases of fasting, first is the post-absorptive phase, that is which is lasting for 6 to 12 hours after last meal. Of course, this is glucose utilization, as we have spoken, that body relies on glucose from glycogen stores in the liver as a primary energy source, and insulin levels decrease as blood glucose levels fall, whereas glucagon secretion is increased to stimulate glycogenolysis. Coming to the next phase, that is the early fasting phase, which lasts from 12 to 24 hours. There is glycogen depletion, as we have seen in the previous diagram, that hepatic glycogen stores are exhausted within 12 to 24 hours, and gluconeogenesis, the liver begins to produce glucose from non-carbohydrate sources. The energy source, the glucose, is prioritized in for brain and red blood cells, while other tissues begin to switch to fat metabolism. If you have seen the place where the glucose goes during the fasting is mainly two organs, that is brain and red blood cells, whereas the heart and the liver, all those depends on free fatty acids. So that is a very important thing which we need to understand. Coming to the prolonged fasting, if you're fasting for more than if you're fasting from 2 to 7 days, of course, there are three things that kick in, that is lipolysis and ketogenesis and protein sparing. Protein sparing is very important because if the protein starts breaking down, you'll start losing your muscle faster. So lipolysis, fat stores in the adipose tissue break down into free fatty acids and glycerol. Whereas if you're talking about ketogenesis, the liver converts free fatty acids into ketone bodies to provide an alternate energy source for the brain. The most important thing that which is available for the body during the fasting phase is your free fatty acids, which are converted to ketones or ketone bodies. As we have spoken regarding protein sparing, yes, reduced reliance on muscle protein for gluconeogenesis as ketones take over as the main energy source. Coming to the most important, starvation phase, if you're fasting for weeks, then two things will occur. One is metabolic adaptation, second is protein catabolism. Metabolic adaptation, your body will minimize the energy expenditure and fat becomes the predominant energy source, whereas protein catabolism, in extreme starvation, essential proteins are broken down, leading to organ dysfunction and ultimately leading to death if no nutritional intervention has occurred. So, what are the benefits of fasting? One is weight loss, second is improved insulin sensitivity, third is cellular repair. Weight loss, of course, fasting can promote weight loss by reducing calorie intake and increasing fat burning. Of course, improved insulin sensitivity. Fasting can improve the insulin sensitivity, which can help regulate blood sugar levels and reduce the risk of type 2 diabetes. Cellular repair, they also say that fasting may trigger cellular repair processes, promoting overall health and longevity. So, coming to the last slide, these are the types of fasting which we see on a regular practice. Intermittent fasting, that you do cyclical periods between periods of eating and fasting. Some of them do it 16 hours fasting and 8 hours of eating. So, whichever is your thing. Alternate day fasting is something else, which some people do fasting on religious days like Ekadasi. They don't have anything, and then they have the food on the next day. So those are called now kind of alternate day fasting. Coming to the prolonged fasting, that is fasting for several days, which is not recommended at all. So thank you so much, and we'll be uploading another video by Dr. Sundar, which talks about detailedly about pathophysiology of fasting. Do watch the video. Thank you so much.